Hey guys, welcome to another video. So today, very exciting topic. I'm going to do a lesson from the Extension 2 syllabus in the proofs topic. So today's lesson is on inequalities, mainly to do with algebra. Now, for those that know the syllabus, there's basically two buckets of inequality questions that you usually get. You either get inequalities that have algebra or inequalities that have calculus, like area under the curve and differentiating to get like turning points and stuff. Today's lesson is purely focused on the algebra side. I thought it's a good lesson. It's quite a nice theme that I want to show you. So let's get started. Now, actually, before we get started, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends, guys. Now, to do today's video, what I would like to do is basically start off with let's start off with some theory, right? Just to get ourselves, ease ourselves in. So, inequalities. Yeah. Because I'll be referring to a number of these pieces throughout the whole lesson. So now, everything sort of starts with this inequality. So in the textbooks, they usually start with like the AMGM, arithmetic mean, geometric mean inequality. We always start with this, right? A squared plus B squared is greater than or equal to 2AB. Now, in my classes, I call this pretty lady grandma, right? And the reason why I call it grandma is because what you find, like a family tree, right? Everybody sort of comes from grandma, right? All the questions you see, the starting point of most questions, if not all of them, start from an iteration of grandma, a type of grandma, right? I call it like grandma with like disguises, right? So for example, very common disguises of grandma. By the way, we can prove this using perfect squares, right? But I'll do that later in question. But different disguises for grandma. So sometimes you might see grandma looking like this, right? And this is basically your that is your AMGM inequality, right? So this is where A equals to, if you in the original grammar, right? If you let that be square root of x, and let B equal to root y, you get an inequality. And just to be absolutely clear, so if your teachers ever refer to AMGM, AM greater than GM. Arithmetic mean is when you go x plus y on 2. That's how you normally find the average of something. And geometrical mean is when you square root it. If you multiply the 2 up, you get that expression there. So first disguise of grammar looks like that. Another common disguise of grammar is when something looks like this, greater than or equal to 2. And in this case, A is equal to root x on y, and B equals to root y on x. And another common application of grammar is when they go power of 4, right? And then that's like 2x squared y squared, where obviously A then is like x squared and B is y squared, and you'll get that. So guys, so many disguises for grammar, but everything comes from the original grammar, right? The OG, yeah? That pink box there, super common. So make sure you know that how to prove these, because you always start with the perfect square. I'll do it in question later on. That's the first point. Second point I wanted to write was we know that perfect squares expand with, I'll rearrange it slightly, right? X plus y squared plus 2xy. Yeah, because I really want to get to the point that x plus y plus z squared, perfect square of 3 terms, is x squared plus y squared plus z squared, plus 2 in the middle, guys, right? xy plus xz plus yz, right? Yep, is that okay? Thought I'd throw that on the board because I'll be using that later on. And then thirdly, right, something called the triangle inequality. Make sure you know this, right? So whenever there are questions that basically say, A, B, and C are sides or lengths of sides of a triangle, right? Oops. it immediately tells you two things, right? There's two facts that come out of this. Right? Fact number one. Right? If they're sides of a triangle, so if you whip up a triangle, right? A, B, and C, what's that tell you immediately? A, B, and C are greater than 0. Yeah, not even greater than or equal to 0. Can't be 0 because then that gives me it doesn't give me a triangle, right? Yeah, it doesn't give me a triangle, so greater than 0. Yeah. And then the second thing is, and this is important. Now, you can sort of see in the diagram, right? The side C, yeah, can never be bigger than A plus B. Yeah, it's actually small. A plus B is flat like that, right? If you open up A plus B, it removes the triangle, right? It basically flattens a line and you get like a straight line. So basically, you get the inequality that C is less than A plus B. That's important, right? It gives you two facts. The first one is that all the sides are positive, and the second one is that any side, right? Maybe for the last one here, I'll be more general, right? So more comprehensive. So C is less than that, and obviously B then is less than A plus C, and A is less than B plus C. Yeah. So basically, any side is less than the sum of the other two. Well, that's important, guys. With that little introduction of theory, let's go through some of these questions from past papers. Now, the first question I have is from the CSSA paper 2010. Guys, this question has been recycled so many times. I've seen it in so many past papers, right? So, part A, NB positive, you can see there's grammar in disguise, right? That's grammar. We can prove that. Also, I'm going to show you today something that once again, this is what I call it. No idea what your school calls it. There's a dark side and a light side, just like Star Wars, right? Of doing this question. If you do it the dark side, some teachers give you 0 marks. The light side is always preferred, but sometimes some questions you got to go dark, and I'll explain what I mean in a sec now. That one there. Second part, that third part, okay, for 3 marks. Okay, cool, easy. Let's get started. So now, this is the dark side, right? Yeah. So when you go dark, the way you go dark is basically you start with the question itself. And the reason I call it the dark side is because, why teachers don't give you full marks for this is because you can't start with the inequality itself that you're proving. It hasn't been proven. So you shouldn't prove it. But some teachers allow you to do this, and then you go common denominator on that. And then times that up. And then now we know that's original grammar, because if you move the 2AB into here, you get A minus B 0. And then if you went dark, what you should say is then which is true. Yeah, because any perfect square is greater than 0. Now, the dark concept is flawed because you started with something that wasn't true, and then you basically proved that something is true, right? Now, the way dark side works, right? This is dark. And then basically, if I reverse engineer this, that's light, right? So the light side of doing this question is actually really easy, right? You basically start, the light side is good because you start with something that's true, and you start with, so you literally reverse engineer this. In fact, I'm lazy, so I'm just going to do this, right? Copy that as the next step, and you literally, step by step, yeah, reverse engineer it, right? Yeah, because you started with something that's true, and then you slowly work your way towards the thing you have to prove, right? Yep. And then you go logically, therefore, done. So the light side is always preferred, 100% always right. Dark side depends on your teacher. but I thought I'd put that side by side for you guys. Now, if there are ever questions that are hard, right, and you need to go dark in the corner of a paper, and then once you get the answer to something that makes sense, reverse engineer it as your answer for the right side. That's how I would do it. Yeah. All right. Now, step 2, guys. Question 2, you can see now for question 2 and 3, I'm going to be a bit sneaky and go, this is the left-hand side, right? Now, once you call left-hand side, right-hand side, you can actually then work on it, right? So for example, left-hand side is a plus b, 1 minus a plus b, or 1 on b. And then I can algebraically work on that. Now, if you expand this, it's pure expansion, and that's all you do, right? What do you get? You get a times 1a is 1. A times 1, that is a on b. That times that is b on a plus 1. Now, I know, right, that this from part A is greater than 2, right? So then what I can write is that this expression is then greater than or equal to 1 plus 2 plus 1, which equals to 4. And you go, which equals the right-hand side. Therefore, left-hand side is greater than or equal to the right-hand side. Tick. Right, so let's play that through again. Left-hand side is that, expand. I know that this blue part is greater than 2 from part A. Then this whole expression now is greater than or equal to 1 plus 2 plus 1, which is 4. Boom, done. Easy peasy, guys. Yeah, make sure you capture that point. And then part 3. Now, part 3, just reading, all right? There's a C. And for those that have done a few of these questions before at school, right? Whenever there's C, generally speaking, you basically go from A. Oh, so from 1. A on B plus B on A greater than or equal to 2. Then you go similarly. Oops, spell that better. A on C plus C on A and B on C, C on B. Yeah, and then I'm just gonna, now what should I do? Then I'll go left-hand side again, right? So left-hand side and then right-hand side, right? Okay, but I have these facts, right? Now, how much space do I have? Guys, I'm not gonna try to squeeze it in because I might end up needing space. I'm just gonna move this. Perfect. Okay. All right. So left-hand side. Let's A plus B plus C. 1 on A, B on C. Guys, expand, right? So A times all 3, B times all 3, C times all 3, right? Right. So then you get, now A times that is 1. A times that is A on B on C, B on A, 1, B on C, C on A, C on B plus 1. Okay. Now we pair them up, right? We basically go A on B, B on A. That's the first couple, right? And they're bigger. Yeah, that's bigger than 2. Second couple. Yeah, A on C, C on A. They are bigger than or equal to 2. Third couple. B on C, C on B. That's this guy and this guy. They are bigger than or equal to 2, right? And then there's 3 ones there. So then you go, this expression then would be greater than or equal to 1 plus 2 plus 2 plus 1 plus 2 plus 1. Yep. Yeah, which equals 9, which is the right-hand side. Right? And then I'm done. Therefore, left-hand side greater than or equal to the right-hand side. Done. So this question, right, started off with a grammar in disguise, right? A on B, B on A. Just make sure, go light on it. And for part 2 and part 3, left-hand side expand, use part A. Number 3, expand, but have 3 versions of that disguised grammar for you to do the question. Guys, how's that? Yeah, next one. Let's have a look. Right. These from North Sydney Girls. So what do we have here now? That looks like a grammar, doesn't it? Yeah, that looks like a grammar because if I move it over, it's a perfect square. Okay. I think this question, the hardest thing is not really, it's not really anything actually. It's just they use different numbers and it just looks out of kilter, out of whack. So that one there. Okay. And last one there. Okay. All right, let's do this. That one. Now, you can go dark on this, right? And I'll go dark once more for you guys, right? Just to illustrate what that means. So go dark basically means you start with a question, right? Which is naughty because it's not true yet. You can't start with an inequality. That's not true. But if I did, move it over. A minus 3b squared, which is true. And if I go light, all right, I literally copy and paste and reverse the order. Group that. So start with the fact that's true, expand, and move the 6ab over. Done. Simple as. How's that, guys? Yeah, not too bad. Now, for the next part, it feels like, let's see, it's not symmetrical, right? A, B's, and C's are not symmetrical. That's actually quite important. But it does have A, B, C, so I need 3 versions of it. The question is, which 3 do you want? Because now I'll show you why this is important. Because right now, my part A is asymmetrical, right? There's A squared there and B squared there. One's got 1 in front of it, one's got 9 in front of it, right? That asymmetry is actually what they sort of use for part 2. So you go from 1. Yeah, I'm just going to copy it. A squared plus 9b squared greater than or equal to 6ab. Yeah, similarly. Yeah, similarly, b squared plus 9c squared. Now, I want 9c squared there, right? I can see it there, 9c squared. It's greater than or equal to 6bc. Now, I probably don't want, now what don't I want? Probably, so I'm missing, I've done A and B, I've done B and C, I'm missing A and C, right? So, and now, if you did this, I think it's wrong because if you did c squared, 9a squared greater than 6ac, which is absolutely right. So the purpose here is for me to add it through, right? If you add it through, it's very symmetrical. The ABCs and the, it's very symmetrical. I sort of get 10 of each, right? I don't want that. So in this question, the trick is to swap these 2 letters, right? And make that into a squared and a c squared again. Because then the c doubles up to 9, which is good. I get 10 B's and 2 A's, and then when I divide by 2, it works, right? Just be very careful. Now, so once you do that, and then we go this guy plus this guy, this guy plus this guy, so plus the left-hand side and the right-hand side, and I sort of get like 2A squares plus 10B squares plus 18C squares. Yeah, sometimes you just got to react to the question that you want, and that's like if I factorize a 6 out. I get 6ab plus bc plus ac, which is what I want because I divided everything by 2 and I got it, right? So I get a squared plus 5b squared plus 9c squared greater than 3 of these. Yeah, pretty easy, guys. Now, hopefully that was okay. Might park that working out downstairs so I get space. Okay. Last one. Let's see what we're working here. Oh, the last one also gives you this, right? And I probably need that, and this is probably important. So prove that that equals that. Okay. So that looks like it's the top part as well. So, okay, cool. Now, starting with that inequality, right? So part 3, it's given that A is bigger than B, bigger than C, bigger than 0, right? So somehow, right? Somehow this question went from this bit to this bit, right? Yeah. So we just maybe make that link in there somewhere, right? So let's see. Okay. Now, and it's all BCs. So it's like they've just made AB and AC in terms of BC somehow. So maybe, let's see, in terms of AB into BC. So right now I know that A is bigger than B. And since it's positive, C is positive, right? C is greater than 0. If I multiply both sides by C, AC is bigger than BC, right? Yeah, I'm gonna probably put that into AC bigger than BC. So I'm gonna put that into AC over here, right? I'm gonna replace, use colors. Oh, maybe I'll do this one. So let me just copy what I did down here. Yeah. I'll show you what I'm going to do. Right? So right now, I've just established that this guy is true and AC is bigger than that. So I'm going to replace the AC with this one and say this guy is bigger than BC. Similarly, right, I know that B is greater than C. So I multiply both sides by, what should I multiply? I want to get rid of AB. Ooh, so maybe no, I won't use that one. I'll go A is bigger than C and multiply both sides by B. Yeah. So A and B is positive, so that doesn't change the inequality, right? And then I'm going to replace this guy. So AB, there, I'm going to replace that. AB is bigger than that, so this guy's bigger than BC. Since both of these are bigger than BC, I can sort of say that this side is bigger than that, which is bigger than 3 if I put in the BCs now. Yeah, which equals to 3 times 3 BC, which equals to 9 BC. Yeah? So this one here, you can go from part 2. Yeah, done. So let me replay that back, right? For this question, it was all about this inequality, actually, right? By picking apart both of these, my intention was I can see in the question that the left-hand side looks exactly the same. It's the right-hand side that's a bit different. The right-hand side only has BC. So my aim was to find an inequality, which I found 2, to replace AB and AC in terms of BC. That's what I've done. Guys, how's that? Is that all right? So once again, that grammar statement at the start, different perfect square, but you can go dark or go light, whichever way you want to, or sorry, not whichever way you want to, whichever way your school wants you to. But go light, it's flawless, while dark, I'd say more than 50% of the time you get it wrong, right? Okay, so another one. Now, this question, once again, this question is recycled heaps. Again, GCSE questions, very good. Right? So, grammar, that is the AMGM grammar, right? Then I got to prove that, and then when W is that, prove that. Okay, yeah, pretty straightforward. You probably have seen this before at school, guys. Let's dive right in. So part 1, you know what? I'm not gonna go dark anymore. Let's just go light. So I know, right? So when you're here, right, you can sort of start with, now this was the grammar. So if original grammar was a squared plus b squared greater than 2ab, right? In this case, then a would be root x, b would be root y, right? So then I'm smart enough to go, I'll start with the perfect square because that's where all the inequalities sort of start. If I expand that, I get x plus y minus 2 root xy. So therefore, I've got the grammar that they want me to get. Yeah, perfect. Yeah. Now, next one sort of introduces, I have xy, they introduce 2 other letters, so it sort of makes sense to go similarly. Yeah. So if you go part A, Don't need to just tick. Yeah, from 1. Yeah, similarly, w plus z is greater than 2 root w z. And then, guys, just like before, I will add these two, right? You go, therefore, x plus y plus z plus w. Yeah, I'll switch the order because that's what they want in the question. Is equal to 2 root xy. Yeah, 2 root wz, right? I call this, in my class, I call this Halloween grammar because it's a grandma in a grandma costume, right? That's what it looks like. Can you see, right? Grandma in a grandma costume. Why do I say that? Because this grandma here, right, had the expression when you have one term add with another, it's greater than or equal to 2 times square root. Over here, can you see one term plus another? I need to apply grandma to that as well. So it's like grandma hidden, right? In a grandma suit, right? So I know that this guy, if I pretend that this is x and this is y, I know it's greater than or equal to 2 root x times y. Does that make sense? So 2xy, right? So same as what I have here. So this grammar basically is that x plus y is greater than or equal to 2 times square root of xy. This is x. This is y, greater than or equal to 2 times that, right? Perfect. All right, let's clean up the algebra then. This side here then becomes, 2 comes out, so that's 4. Square root of a square root of x, y, w, z. Guys, that is, now they want me put in index form? Yep. So that is 4, 4th root. Oh, not index form, sorry, 3rd form. Yeah, got it. And you can write your expressions like this, right? I got this guy greater than this guy greater than this guy, which is equal to that, with that. Therefore, this original is greater than that, right? Perfect. The teacher's going to be happy with that, right? Done. Now, part 3. What's it saying? Okay. Let W equal to that. Prove the 3 version of this, right? Okay. So let W equal to x plus y plus z all over 3. Now, so before I do it, I realize I don't have space. So I'm gonna do that up here. But before I do that even, I'm gonna copy this. It's gonna create a version of the question. So this is me just being lazy to write the answer of part 2 out nicely on the line. Okay. So that's the expression I got from part 2. So from 2, right? Now, so what they want me to do is basically sub this guy into there and also into there, right? Yeah, into there and there. Now, can I ask a favor? All right, let's sub it into the left only, and I'll show you why. You just clean out. You can sub it into both, right? There was a lot of answers I was saying sub it in both. It just doesn't look pretty. It's just sub it into the left. I'll show you why. X plus y plus z plus x plus y plus z on 3. So on the right hand side, just leave it as w, y, z, w, right? Leave the w, don't sub it in yet, just the left. Hey guys, one of these adding with a third of these gives me 4 on 3, right? Yeah, so 4 on 3, x plus y plus z greater than 4 4th root x, y, z, w. Now, You guys okay that the 4's cancel out? Yeah, 4's cancel out, and what you realize is that x plus y plus z on 3, that's w, right? So I'll put w back in now. Just makes my algebra a little bit easier. X, y, z, w. Guys, fourth both sides, the power of 4 both sides, to get rid of the fourth root. So I get w power of 4 greater than or equal to x, y, z, w. Divide w over, w cubed, and then cube root both sides. Now, how do they want me to get my answer? Cube root, okay. So I just sub w back in, so therefore x plus y plus z on 3. That x, y, z, tick, tick. Yeah. So for this one, all about algebra. You sub it in. I left the w in on the right-hand side because I know you don't have to, by the way. You can leave it in. You can put in the w on the other side. It just makes it heaps messy. That's cleaner. That's nice, guys. Let's move on. Yeah. Now, I've got 2 more questions. I've got one from Kings, and the last question is, I can't seem to find where I got it from a past paper, but it's a really nice one that basically that I want to show you. But let's do the Kings one first. Now, the King's question, in a 4-unit question, 4-unit paper, it's a hard question when there's a question that's worth 4 marks, and it's just a one-liner, right? You look at it, it's not necessarily super hard. It's just not your standard, right? Not your standard, but it actually comes. This one here, the way you sort of see it, right? What you're supposed to sort of realize firstly, whenever you have 3. Generally speaking, right, when you have 3, the right-hand side is generally symmetrical. And by symmetrical, I mean you shouldn't have more of x squares than y squares or more y squares than z squares. They should be all sort of proportional. This one isn't, right? You can sort of see. Why? Because you can sort of see that there's one fraction of 1 on yz, one fraction of 1 on xz. I'm expecting another fraction to be 1 on xy. It's not there. Whenever it's asymmetrical in this nature, right? What that sort of tells you, and I say this to my students, right? Normally when there's 3 of them, you basically get grammar where there's 2, and then you basically go similarly. The other 2 cases, then you add, right? That's what we do. So just a visual. So normally we do what we're saying over here, right? Yeah, normally when there's, you do a grammar and then you have 3 of them, right? For this one, you probably won't, right? In fact, this one here, your starting grammar, right, which is a squared plus b squared equals to, sorry, not equals, right? It's inequalities. Going to equal to 2ab, right? That is your starting grammar. And then what I want you to see is you're going to try to manipulate the right, the left-hand side to make it fit within here. And a smart thing to do is you pair it up, right? So you pair it up. You basically say this, here's what I'm going to do. Crop that. Yeah. Right. I'm going to crop that and then go, let this guy here and this guy here be my, that's a squared. And this thing here, let that be b squared. Yeah. I'm going to do it twice, right? And then over here. Now, how do I know to do it only twice and not 3 cases? Because it's asymmetrical on the other side, right? So smart thing there, that's a squared and that's b squared. And then on this side here, I might go, this is a squared. Yeah, and these 2 are b squared sort of thing, right? So I might swap it around. So go, this guy's a squared. Yeah, and this guy's b squared. Is that what I should do? Let me see. I think it is. Yeah, I think it is. So let's see. You know what? Let me do the first one first. I won't do the second one yet. Now, let me do the first one. So see where the algebra takes me, and then I'll illustrate why that second case made absolute sense, right? So this guy here, if this guy is a squared, b squared, right? So I know that a squared plus b squared right, is greater than or equal to 2 times square root of a times square root of b, which is a bit of a monster, right? Now, let's see where this takes me, right? I'm going to put both of these underneath the same square root on this side, right? Now, so when that happens, I'm going to common denominator, so y squared. You know what, before I do that, just to get my algebra right, so I won't common denominator yet. So I won't combine them yet, I'll just do that. Common denominator here, x squared, y squared. And it becomes what? X squared, y squared, z4. Now, how do you know you're on the right track? Let's go back up, see what that, can you see? Look at that. That looks exactly the same as that. Brilliant. And on here, I can sort of see that the x squares cancel out. Oops, I did that wrong, didn't I? Because that should be z squared. Yeah, and then on the bottom, y squared, z squared, they took it out of the square root to make it the fraction. So perfect, exactly what I'm after. So take the x squared, so I'll do it in 2 steps. Yeah, over y squared, z squared. And then take the y squared, z squared out. Comes now, so 2 there. Yeah, there isn't a 2, but hopefully things would help me play out. YZ square root x squared y squared plus z squared. Yeah, cool. Now, so I mean, if you were sorry, Z4, if you were after a dead giveaway, right? The dead giveaway for you to get this right is this Z4. So there's Z4. Now the next one here, I want X4. How did I get the Z4? The Z4 was when I cross multiplied that and that. So it feels like, right, the equivalent on this side is going to be square root, right? Now, if I wanted to cross multiply, I probably want like Z squared on X squared plus X squared on Y squared, right? If that's the case that I want, I'm going to back solve. So that's like, which two are they? That's like this one and this one. I'm going to call these two B squared. I'm going to call this guy A squared. Does that make sense? Like just to target the X to the power of 4, right? That's how I'm going to do it. So let's make that happen. So over here, I've got so much space. Doesn't make sense. You know what? I've got so much space, guys. I'm just going to make it symmetrically laid out. Okay. So A squared on B squared plus, so A squared plus B squared greater than 2 times root A, so root A squared, which is A, times B. Yeah, I know when I cross multiply, I'll get the expression, right? So if I put them both under the square root, I'll get x4 plus y squared z squared. Great. Now, this guy goes away. And on the bottom, now I'm going to, I think swap the order around, right? Yep, they want the x or 4 on the right. So they want y squared z squared plus x4 all over. Is that right? X z is checking. X z, yeah, perfect. Okay. All over x squared z squared. They took that out. Now that you got the two branches that look effectively the same, right? That looks exactly the same as that, sort of, with the two there. Yes, I get that. This part looks like this part. Now, once you get the two, add them, right? Add the left, add the right, because then there's two lots of the left. So I divide everything by 2 and I'll get my expression, right? Then you go, therefore, right? If I call this guy number 1, I call this guy here number 2, I said 1 plus 2. Yeah, I get therefore 2 lots of x squared plot over y squared over z squared over x squared is greater than equal to 2 on yz x squared y squared plus z4 plus 2 on xz root y squared z squared plus x4 divided all by 2, right? Yeah, take 2, 2, 2, and therefore copy and paste that. Therefore, I have what I want. Tick, tick. How's that? That's a nice question from Kings, right? It's a nice question because you have to choose, you have to pick and choose the two combinations that you want. Sometimes it's about those little things. In this one here, the power of 4 really gives you an indication of what you should call b squared, which is the term with two of them, so you can common denominator to get the power of 4. Guys, how's that? Yeah, I've got one more question, right? One more question. Now, this one here, really nice question, part B in particular. Let's do it. So, PQR triangle, right? Sides of a triangle. So immediately, right, we know that PQR are greater than 0 individually, right? But also triangle inequality, right? Where P is less than Q plus R, etc., right? All right, let's do this, part A. Now, part A just requires you to prove this. So for those that have done this before, right, part A, we just add them, right? So, sorry, we start with original grammar. All right, so with original grammar to PQ. There's 3 of them, so maybe go that. Now, whenever you do these questions, I always tell my students, teachers allow you, if it's a complicated question, they allow you to take the original grammar as gospel, right? They don't actually, oops. Sorry, my PowerPoint is thinking. I've crashed. Oh, no, hasn't. Good. 2PQ. They let you take that as gospel, right? So similarly, P squared plus MR squared 2PR and Q squared plus R squared greater than 2QR. And then you add, right? So add, right? On the left, you get 2 of each. One color. And divide by 2 and you got it. Yep, divide by 2, got it. Yep, nice. All right, guys. Now that we have that, right, we need to prove the next part. Now, the next part is super key, right? I have a perfect square in the middle. So a perfect square of 3 terms in the middle. And the inequality works really nicely. On the left-hand side, it's 3 times the 2 pairs. On the right-hand side, it's 4 times 2 pairs. And then subtly, one's a less than or equal to, and the other one is just less than, right? Okay, so whenever I tell my students to do this, right, I tell them it's a story with 2 halves, right? The first half is basically over here. We'll do that first, right? Story of 2 halves. That's half number 1, story number 1, and then story number 2 gets proven later, right? So part B, part B, let's do first part first, right? Part B, yeah, so for the first part of the story, right? So first part of the story, we're going to use what we use from part A. Copy that. Move it over a bit so I can say the word from A. Yep. Now, what I want, by the way, I'm just freestyling it. So I want perfect square. Now, remember, so in my rules, right, in my original theory, I said to you a perfect square looks a little bit like that. Yeah. So if I want that to be the perfect square, so I need to transform the right side, right? I want this to be this side. Is that right? No. The question has less than, so I need to swap this around first, right? So once you copy that down, maybe flip the side. So PQ plus PR plus QR is less than or equal to P squared plus Q squared plus R squared. Okay. Now, I want this into a perfect square. I want this to look like this, right? So right now it's got this. I'm just missing this bit. So I'm going to add that pink part to both sides, and then I'm done, right? So if I add 2 times PQ plus PR plus QR to both sides, right? So I add it to this side, then I add it to the other side as well. Yeah, this side here becomes a nice perfect square. And the other side is 3 lots of this, which is exactly what I want for the first half of the story. Yeah, tick, tick, right? First half of the story, done. Yeah, cool, guys. First half now, second half requires me to actually use that triangle inequality piece, right? That hasn't been used yet. So let me zoom in. Okay, second part of the story. Yeah, I go since P, Q, and R are sides of triangle, right? I've got P is less than Q plus R. Yeah. Now, if P is less than Q plus R, I'm just going to use that and do a little bit of a manipulation, right? So move the R over and then square both sides. Yeah, square both sides. Yeah, and then I'll just, not that I need to, but I'm just going to move the 2PR back to the other side. Therefore, that squared plus that squared is less than Q squared plus 2PR. All right, that's nice. Guys, similarly, I'm just going to do the 3 combinations of this, right? So similarly, yeah, P squared plus Q squared. And when that's P and R, that's Q, so this must be R squared plus 2PQ and Q squared plus R squared plus QR, and then add them. Yep. And then add them. Is that right? Yep. And that's to add left and right, all 3 of them. And I get therefore 2 of these. Less than. Now what do I have here? I've got 1 of these. plus 2 of these. 2 times PR. Collect this one with this one, so move it over. Because there's 2 of these, 1 of these, so therefore you get P squared plus Q squared plus R squared is less than 2 of these. And just like what I did upstairs, I want the left-hand side in this case to be a perfect square, right? Because it's got P squared plus Q squared plus R squared. So I'm just going to add these two. Now, what I'm going to do, if this is okay, just going to move this down here. Oops, wrong thing to move. Just so I have a bit of space. So move that down there and move that there. Perfect. And I'm just going to borrow this pink line to add to both sides, right? Okay. So once I do, that becomes a perfect square. And then this side, 2 of these plus 2 of these, 4 of them. Guys, right? And once you get that, we got 2 parts of the story and proven, right? So I've got, on one hand, I've got this guy is greater, so less than that. On the other hand, I've got the same perfect squares less than 4 of these. So then I could say, therefore, right? Let's put them together, right? So I go, therefore, that expression is less than that expression, right? And I'll get rid of the highlight and then put this back on this page. And I got it. Guys, that's inequalities. Now, the analogy of grammar is a good one because everything comes from that perfect square expansion. Sometimes grammar is in a disguise with square roots, squares, fractions, yeah, but they all sort of stem from grammar. Whenever you do inequality, sometimes you might see 3 letters, in which case you start with the 2 original grammar and then you have different iterations and then you generally add through, right? Sometimes you just got to pick and choose which letter to choose when, right? So like the one where we sort of changed it around because it wasn't symmetrical, right? Which one was that? There was this one. Yeah, wasn't symmetrical. The king's question was hard because there was only 2 of them. When it's asymmetrical, target where the asymmetry can be proved. So for this one, the power of 4 was what I looked at to try to target my algebra. And then the last question, a really neat question that tied together 2 sides of the story. Part 1 is pretty simple story. Part 2, triangle inequality. Make sure you can do that because I've seen that part of the question in like a separate question standing by itself in past papers. Guys, hopefully that was okay. If you liked that video, please subscribe to the channel, tell your friends and like the video. Guys, I'll see you at the next one. Thank you.